My name is Daryl Kennedy. I'm an environmental engineer, professional environment engineer by trade. I've worked on Autodesk Civil 3D in the design and consulting industry for about 10 years now. And I realized that there are a lot of basic functions that users do not know how to use, and they're not taught that in college, and then they're kind of thrown into the industry without much training. So I'm going to make a series of instructional videos. I'll start off with the basics, and I may move on to some more advanced techniques or skills as I progress. This is going to be the first of many. So the point of this video is to show how to create a surface from a point file. I'll go over two different point file methods, and I'll do it all from scratch, and I'll do it live. So any troubleshooting and errors that I run into, you may run into as well, and hopefully everything goes smoothly and you guys can get anything from this. So this is creating a surface from a point file. I have a standard template which I like to use. I've created over the years. We'll start with this template. It's basically a blank file. You could also do the same by creating a blank file here, or whatever template you like to use. I'm going to save this file somewhere in my instructional videos. Create surface from point file. It's good to have good file structure and a proper naming of your drawing file. So I will call this today's date and create surface from point file. Save it here. Yes. Okay. First thing you would like to do is make sure that you set your horizontal datum to be consistent with whatever your point file is in. So my point file, I'll be going over two of them today. I'm working in Autodesk Civil 3D Imperial 2025 build. To set the drawing, you go into your tool space. There's a few different tabs. I like to go to my settings tab. And also, as a reminder, there's many different ways to access your settings and do various commands. Most of them can be done here through the toolbars. A lot of them can be done through the command line. I use a mixture of both. I have my command line here, so hopefully you guys can follow along with everything that I'm doing. So I'm going to go into my tool space, over to the settings tab, right click, edit drawing settings. Here, this will bring up your units and zones. There's a few different tabs here. You can set ambient settings, etc. But we're just going to start here on the units and zone. I know that my project is located in the United States, in the state of New York. I'm going to go down here. Coordinate system that this survey data was collected in was North American datum of 1983, New York State Plains. There's several different ones. I'm in the central zone, and I'm using feet as my unit of measure. So it'll go here. If you have the code, you can simply enter the code. So I'll go cancel just to show you guys you can do it a different way. NY83. Yeah, same thing. Okay, so you apply, press OK. Now you have your coordinate system. I'm going to bring up my file explorer that shows my different point files. These three different point files here, they are of a bathymetric surface of a lake within central New York. The surveyor, the hydrographic surveyor, has provided it in three different grid spacings. They have a 1 foot spacing. You can see it's a very highly populated file, a 3 foot and a 5 foot. I'm going to import all three to show you guys the difference in the speed and the file size and kind of what those may look like. So anyone that's dealing with hydrographic data or bathymetric survey data, they need to import that existing conditions or that as-built data and utilize it as part of their design. This is going to be a great video for that. These here files are XYZ files. They're standard that come out of a bathymetric surveyors. They typically produce XYZ files. I believe it's ASCII is the software that it comes out of. I also have some files which is typical of topographic land surveyors or other survey data, maybe even just a GPS. Typically you'll get points in a XLSX file, so just a standard Excel file, and I will show you how to import these as well. So as an example, just to open up this file and show you what they look like, I'll open it using Notepad. XYZ, as you would expect, is for the easting, northing, and elevation. So it's set up like this, and we're going to import this file. So what you want to do is start by making a blank surface. Proper surface naming is always important as well. So we'll say V for survey. It's existing grade, so I'll use existing grade. It's a bathy surface, so I'll say bathy. Typically, I put the date that the bathymetry was collected, but not necessary in this scenario since it's an instructional video. And then we'll do all three spacing. So we'll start with the 5-foot grid. Here, this is where you can say, this is existing condition surface survey data from a bathy event that occurred on month, day, year, and is on a 5-foot grid. Not necessary to include a description, but if there's going to be multiple other users, or maybe you're not sure when the next time you'll look into this file, it's always good to get an understanding of where this came from. Style, I'm just going to turn it on 1-foot and 5-foot design so it's easy to see for everyone. We're going to press OK. So now we have a blank surface. I'll go through the steps quickly of making the other ones. What? Okay. Now we have 3 blank files or surfaces, and we need to add data to these surfaces. And there's a variety of ways to make surfaces, obviously, but we're going to discuss today how to create them from a point file. So under the surface definition, by expanding the surface, we'll start with the 5-foot process. You go under definition here, and you'll see point files. We want to add a point file. We'll set this in a moment, but for now, we select our surface here. I'll select the 5-foot. It's okay. Not many options. When you select a point file in XYZ format, you'll get a northing easting elevation or easting northing elevation. So XYZ, I'm going to do easting northing elevation. I'm not going to do any adjustments here, and simply select this after I've added my file and press OK. Here it's importing the surface very fast. I'm going to zoom to all extents so that I can find my surface. And here we will see that, let's check and see if this is about in the general right location. So I'm going to go into the geolocation tab, and I'm going to turn on the Bing aerial. And it looks about right. Okay. We'll quickly turn on the points and triangles just so I can show something. Generate it. I may need to make an adjustment here to my styles. What I'm doing now is adjusting the size of my point. Much better. Okay. So as you can see, most of the point data is here, but then we have these large triangles. And for those of you who don't know, contours are developed from triangles and triangles are made from points. So it all starts with the points. Okay. Now, when you have long triangles like this, you're going to get some odd contours. That's because this data is not realistic. It's not what it's meant to be. Here's an example. Now, you can go through the process of editing the surface by deleting lines if there's not too many. Do an example here, right? It looks a lot better. But that's not very efficient. So I'm going to delete that edit, regenerate my surface. And I'm going to show you guys how to fix this in a manner that may work. So we'll go to the build under the definitions tab. So I'm in surface properties now, definition tab, build. And here we have this use maximum triangle length. It's currently set to no. I'm going to change it to yes. And it's going to state, how long do you want your longest triangle length to be? So that means any line that's longer than a certain number that I put here will be deleted from the surface. So just for informational purposes, I'll do two different values. We'll start with 50. Okay. Press apply. So any triangle that's longer than 50 feet will now be removed from the surface definition. And see how it automatically removed all the triangles that were in between? Now to redo this or undo this and show you how it previously looked, I'm going to simply turn this off and rebuild it. Press OK. And you can see all these triangles here that are now part of the surface. Another thing we can do is set it to a very small tolerance. So if we change that tolerance here maybe to 5, let's see what happens. We might probably lose a lot of data in it. It might not be, let's just change it to 10. Apply, rebuild. Okay, now we have these holes in our surface and the edges are very jagged. This is because this is where areas where there maybe wasn't a lot of data collected. Like there's a bridge abutment here. So we didn't get a lot of data. They didn't process it well. There's a hole here as well. I know that there was a groin structure up in here that they were unable to collect data. So this is now showing up and we have all these issues with the surface. So it's a little bit of trial and error depending on what your surface is processed to, or what your grid spacing is, or maybe how many feet are in between your typical surface. This won't usually work for topographic land surveying. It'll work for LiDAR and bathymetry, which are usually processed on a grid based. I'll turn this back to 50. This 50 seems to look pretty decent. All right, looks good. Now we're going to bring in a few other point surfaces and just show you what the difference is between a 5-foot process grid and a 3-foot process grid. So again, go into the definition, add point file, Going to add now the 3 foot. It's an east and northern elevation. Press OK. Okay, and you can see that there's a slight variation. I've selected the 3 foot grid. We're going to turn this on to contours and triangles. And I will copy this surface style. So we're kind of indirectly showing a few different things here in Civil 3D, but that's just the nature of the beast. You have to know how to do a few different things to show our point. So even though this video is about creating a surface from a point file, you're getting a crash lesson and a few other items. So I'm going to make a copy of this surface style, and I'm going to change the color of our points to something else, just so that we can all see what's going on. How about green? Hopefully this works. It did. Okay. So you can see that the 3 foot grid is a much tighter tolerance than the 5 foot grid. Here's the 5 foot spacing, and then there's many points of the 3 foot grid within there. Okay, we'll turn both of these off. I'm gonna turn this one off, no display. This one off, no display. And turn the 3 foot back on, just to show you that we have not yet processed this or set the maximum triangle length. So we still have this issue. Again, we'll set this. 50 seemed to work well. We'll do 50. Rebuild. Takes a little longer to process now because it's more point heavy surface, so it's got a larger file size. So I don't lose anything. I'm going to save my surface, or save my drawing now. And just to quickly show, save the back file. We still have these two DWL and DWL2, which because the file's open, but there's no MMS file. And I believe, based on the size of this surface file here, if we import it, it should create an MMS file. And in simplistic terms, an MMS file is essentially a way that Autodesk Civil 3D stores surface data outside of the DWG, so that the DWG file itself here is not very large. So the file size here is about 25,000 gigabytes. If we were to put more point data in here, so let's bring this one in and see what happens. It could potentially be too much to store into the file, making the file size too big. And in order to increase the performance of the DWG file, what it does is it stores that surface data in what they call an MMS file. So let's put this in. This may take a moment only because the surface is so large. Let's bring it in. Okay, here. A little bit slower. I do have pretty good internet connection, so maybe a little faster than usual. But I would expect some delay on your end. Oh, it's still reading. Yep, very large file. Right. So we're going to turn off. And as you noted, there's many different ways to modify or get to the surface properties. I just right-clicked here in the tool space. I'm going to turn this one off. But you could also just click the surface, and then you can modify the style here as well, which we'll do here. Changes to contours and triangles. Taking a while to show all the points because there's so many points in this file. All right. Now to show an example, on the last one, we had quite a bit of holes in our surface when we set that to 10. So let's set it to 10 again, the maximum triangle length, and see if we have less holes. And we should have less holes because of how fine this surface is processed. But I may be wrong. Again, I'm doing this all real time with you guys so that you can see exactly what I'm doing. Still quite a few holes, but the tolerance of the tightness of the surface is very tight. To speed this up, I'm just going to click on the surface and change the surface style to something that's not showing the points. Just make it 1 in 5 design. Significantly slower working with this higher data set. And I'm also going to change the definition back to 50. What I'd like to show you next is when I save this, it should create the MMS file. And just so you're aware, if you're ever to share a DWG with somebody, you're importing a point file, and you want to share everything, you'll need to share the point file, the DWG file, and the MMS file that it creates. The only way around this is to create either a data shortcut and promote the data shortcut, or you can create a snapshot of the surface here. And I'm not going to show that in this video or data shortcuts. We'll save that for another video. But let's see if an MMS file. It was. Okay. And so what you can see is the surface was so large that it created this MMS file, which essentially is all the data from that one surface. Not all the surfaces, just this one surface here. And the DWG file still has about 25,000 gigabytes. That's because these 90,000 gigabytes were not stored within the DWG. They're stored here in this MMS file. So that worked out well. Okay, so that's how to import XYZ files and create a surface from XYZ point files. Now I'm going to show you how to import from CSV. So the points that I'm working with under that survey, they're actually in Puerto Rico, and we're using metric. So I'm going to open Civil 3D metric. And while that's loading, I'm going to show you how I received the point file. So I received the point file here as an Excel file. I'm going to open this Excel file. And what you see here, okay, it's not labeled. Is it labeled? Oh, it is labeled. Okay. So what the surveyor or whomever provided this, thankfully, they gave us a point number. They identified that this is the northing, this is the easting, this is the elevation, this is the description. In order to import a point file, a CSV file, and create a surface from it, you need to clear some of this data. It's not all needed, okay? So I'm going to open this, what I call a pnesd file. And you can see here that I've deleted, sorry about that. I deleted this top row. If you don't delete this top row, you're going to get an issue. But we're going to do this all from scratch. So I'm opening this Excel file. This is now the Excel file. Turn auto save off. Delete this top row. So remember, point number, northing, easting, elevation, description. Really, point number is not needed and description's not needed, but we'll leave them for now. So I'll delete. Okay, now we want to save this file as a CSV file. So we'll go to here, CSV. Now there's two different ones. You want to make sure that you choose CSV, comma, delimited. Okay, Luchetti, bathymetric points, CSV, comma, delimited. And then you change, what I like to do so I know if it's, is it the point number is first or what is it? Northing is first. So I just say P, NAS, D, and this will be useful for you later. Here, it happens that I already have one, so I'm going to replace that. Okay, now we can close this. I'm going to open here. I will, I'll just open a blank file. I won't start with my template, just so you guys can all I can show you that there's nothing fancy going on here. I'm going to go to my drawing settings. I'm going to set my coordinate system. I know that it's Puerto Rico 83. So this is NAD 83, Puerto Rico and Virgin Islands, meter. Apply, okay. Just like the last one, I create a surface. So here's contours 2 meters and 10 meters background. Sure. Let's go 1 and 5 design. Okay. All right. Call this V, EG, Bathy, Chetty. I don't know what this has been processed to, if it's a 1 foot grid, 5 foot grid, 3 foot grid. So I'm not going to put anything else. I'm just going to call this an existing grid with imagery from Luchetti. That's okay. Go to the surface definition. Here, let me save this. And I'll call this Rico meter, just to differentiate it from the last one. Thank you. All right, surface definition. Same thing, point file. Here, we're going to choose oh, it's empty. Okay. So here you can choose which file. I'll just do all files so that I can see everything that's available. But I still want to import this CSV file. So I'm going to say okay. All right, much more options. All right. But we know that it's a point number, northing, easting, elevation, comma, delimited. So the reason why I add that suffix to the file name is so that I'm not confused with the easting northing one. I can do the northing easting. And what this does is it states that what this is doing is essentially it's reading your file, your CSV file, and it's stating, okay, I know that the first column is a point number, the second column is the northing, third column is easting, fourth is point elevation, and the fifth is raw description. So when I stated earlier, you don't need the point number and raw description, that's because you don't. You can see here, if I only had the northing, easting, and elevation, I can just do northing, easting, elevation. But if I have all that extra data in there, this would read it wrong. It would think that the first column is the northing, but in my file, it's not. It's the point number. So this would come out very wacky. So I know that the first column is the point number, then it follows northing, easting, elevation, description. So there's many different ways that you can receive a file. You don't always have to have a raw description or a point number associated with it, but you do need the northing, east, and elevation. So we'll say okay here. I'm going to zoom to full extent. Z, E. Here's our surface. Turn this on just to see if we're kind of in the right area. And it looks like we are, right? Let's look to see what it looks like with contours and triangles. Okay. So I don't have my points. I don't have it set up here. So it looks a little funky. Let me see if I can change this. This is why it's important to use a template. Okay, so the point was turned off. So I'm going to turn this little light bulb on so we can see it. And I'm just going to make it red so that we can see it even better. And we're going to say, okay. Okay. And there's our points. All right, so what it looks like they did here is these are transects. So it looks like they developed transects. It's pretty standard of bathymetric surveying. And then they created a surface from these points. And somehow they were able to delineate the shoreline in some manner. Now, I'm not sure what the best way to kind of get rid of all these lines is going to be. We'll do two things. We'll do two things and just kind of see what we come up with. So the first one I'm going to look at is what happens if we change the definition to now this is meters, not feet. So it's about 3 times. So 50 feet would be like 150. 50 meters would be about 150 feet. So let's try 50 meters and just see what it looks like. Definitely not going to work. Let's double it. All right, it's not great, but you know, it'll work for now. And you can still see we have all these issues. So this surface might need some manual editing, which will take some time, you know, deleting triangles, etc. Another thing I'm going to look at quickly while we still have time, 1.5 design. It's a way to cheat, but let's see if we can just extract one of these surface objects. Well, that was nice. So this is the outermost minor contour that I selected. So I'm going to select that. What that does is it extracts the outer contour as a 3D polyline. Only made it a polyline. Well, if it was a 3D polyline, you could convert it 3D to 2D, but it's not. It's just a regular polyline. So I'm going to offset this by 1 meter. Did it work? This may not work. Might be too cumbersome. I'll turn this off for a second just so I can see what's going on. Let's try simplifying this a little bit. We're going to weed this polyline. Then I'm going to flatten it. Let me try to offset it one more time. Let's save this quickly. Offset 5 meters this time, just to see the difference. Okay, that worked. And delete this interior polyline. This is a very crude way. It may not be exactly what you're trying to do, but what we're going to now do is use this polyline to make it a border, an exterior outer border for our surface. So we'll click on it. Go to add boundary. There's a bunch of different ones. It's not a show or a hide or a data clip. It's an exterior boundary. We want it to be non-destructive. Say outer boundary. Okay. Now what I'm going to do before I show you if it worked or not, I'm going to open up my surface property or my layer properties. I'm going to set a unique layer for this. I'm going to call it C Bundy VEG surface. Create a new layer for that. I'm going to freeze it and lock it. I'll just lock it for now so that it cannot be edited. I'm going to change this line, the layer of this line, to that. Very slow since it's a big line. Probably should have used a smaller file. Okay. Now, what goes to plan? When I turn this surface on, I'll even turn off the maximum triangle length, just so you guys can see that it should work. We'll go back to 1 and 5 background. It's okay. Oh, let me change that layer color so we can make sure we see it. Make this red. Yellow. Yellow would probably be better. Right. It worked. I'll reload this just to show. And you can see here that that outer line is now our surface boundary. Okay, and it worked pretty well. And it coincides with the actual surface boundary. And what I'll do is I'll turn off the boundary within this style just so we can see here that it's that yellow line. That is the same surface boundary as this one. All right. So I've shown you guys a few different ways. I've shown you how to import using an XYZ. I've shown you how to import using a CSV. I've processed the CSV file so that it's able to be imported. I've done a few different ways of modifying the surface properties when you have points of that cause an irregular surface or a large triangle length. You can set it in the surface properties. You can add a boundary line. I've shown you how to set the coordinate system. We've done a few different miscellaneous items pertaining to changing the surface styles. So there's been a lot in this video, but the main purpose is to create a surface from a point file. I'm going to save, and that will conclude this video. And I hope you guys have a great day.